Hello everyone, welcome to week 11 of Codivate Python class. As this course wraps up, we're going to be focusing on a final project for the last 2 weeks, and this will be a tic-tac-toe game that we'll be coding in Python. So this tic-tac-toe project will involve applying a lot of the concepts that we learned throughout the course. In our code for the tic-tac-toe game, we're going to have to use our knowledge of dictionaries, functions, print statements, loops, conditionals, and even user input. So all of these topics will be very important throughout our tic-tac-toe game, and we're going to be looking at how exactly we're going to be using them by breaking each one down step by step. Our first step in the game is to make a board. Looking at the board, what could we use to represent our board? If you have some ideas, you can pause the video, maybe jot them down. Think about how could we represent this board in Python? I'm assuming you brainstormed a couple ideas, and now let's go over some of our options. We could use a list, a to-do list, a tuple, and a dictionary. If you have many items, you want to use something that is iterable. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces that we need to store information about. Well, what's the correct answer? How should we represent the board? Well, first, let's look at each option. We could use any of these options. It's just that we have to think about which one is the best one. We could use a list. A list of 9 items could hold a series of X's and O's that represent whatever is happening on our board. However, it's not very easy to think of a board as a list. We could do a 2D list. We could have a 3x3 2D list. That would work out, but it might get a bit complicated with going through the list and indexing and everything, so we're just gonna stick with a one-dimensional representation of our board. Let's talk about tuples. The one thing to remember about tuples that we discussed before was that they can't be changed. But we want our board to be constantly changing after each move, so that is not the best option either. Our final option, dictionaries, is the one that we're going to be going with. We could use the keys to represent the positions. This would be position 1, position 2, position 3. And we could use values to store what is actually at that position. Is there an X? Is there an O? Is there a blank? So one benefit of this option is that we can use the strings as keys. And if we're checking, let's say the user entered something in box 5, we wouldn't have to keep casting the user input as an int just so it would line up with our indexing. We'd have to do that if we use something like lists. But if we use a dictionary, we can come up with our own system of keys. So that's what we're going to be using. Dictionaries, because it would be easiest to work with user input and managing the tic-tac-toe board as dictionary. So how would we actually code this? Let's represent it with a dictionary called board. And we're assigning it with the equal sign. We have our curly braces to begin and end the dictionary. And inside we have all these key value pairs. So this is just the formatting that was chosen to represent the board. We could have all of these on one line, but that wouldn't really look very nice and neat. And this also kind of shows us how the board would look like. We have a key of 1, the string 1, and initially our board will be empty. So its corresponding value will just be an empty string that has a space in it. We're going to repeat this for all the positions in our board. And just so we know what the board is representing, we're going to write down the names of all the keys inside this actual representation of the tic-tac-toe board. So at the beginning, these are the keys, and inside the keys, the values are just blank spaces because the board is empty at the beginning of the game. So it may seem obvious to us as the programmers that all of these numbers correspond to all of these boxes, but the user doesn't know that. So in order to let the user know, we've created a function called demonstration that just prints out how the board would look like and the numbers at each position. And the reason we did this is that it would just let the user know, okay, so if I wanted to enter something in, let's say, the top left, I would do 1. If I wanted to enter something in, let's say, this middle to the right piece, I would enter 6. Just so they know what they have to enter to get a certain output, we have to show this demonstration. And you can see that we're using these vertical bars and this dash plus dash plus dash to represent the tic-tac-toe board. You can kind of see it here. Alright, this is just a bunch of print statements, pretty basic. We have all of them inside a function, so if you wanted to use it later, all we need to do is call the function like this, and our output will look like a tic-tac-toe board. We have the vertical bars intersecting with 2 horizontal bars. We have all the keys, so the user knows, okay, depending on the number I enter, where exactly will my piece appear. Now that we know how we're going to print the board, we're going to use these series of dash plus dash, these vertical bars in between the numbers, and we know how we're going to represent what's on the board with the dictionary. Let's write a function that combines these two concepts, and we'll do that by writing a function. So the function we're going to write will be useful after each turn since we need to print the board after each turn. We are going to write a function called printBoard that takes one parameter, which is the board dictionary. What it will do inside the function is it will loop through the dictionary and print each value to the console using the representation discussed on this slide. So basically having the first value in the dictionary and then the vertical bar. Second value in the dictionary, vertical bar. Third value in the dictionary. Next line is just these dash plus dash plus dash, nothing to do with the dictionary. Then we look at the dictionary keys again, ignore the dictionary keys in this line, and do it one last time for the last row. One hint for writing this function is that we would basically have to replace all the numbers with values inside the dictionary using this sort of syntax. We know if you want to access a value inside a dictionary, we have to use the name of the dictionary and then key. Just a reminder, the name of our dictionary that we chose is called board. So now would be a good time to pause the video, try to write this function, or at least come up with an idea of how you would go about writing this function, and play the video when you're ready to see the code. Alright, let's review how to write this printBoard function. Let's go back to the representation here, just so we can get a refresher. So if we want to get the item at position 1 in our board dictionary, let's go back to our dictionary. All we need to do, let's actually go to the solution now, is do board square brackets 1. This will call the board dictionary. This will find the board dictionary, go to the item that has a key of 1, and give us the corresponding value. At the beginning, since it's an empty board, it will just give us the space. After the space, we have to have a vertical bar so that it looks like a tic-tac-toe board, and we repeat this for the item at position 2, vertical bar, item at position 3. We have to draw on the next line our dash plus dash pattern to keep with the consistency of the tic-tac-toe board, and we repeat this again for all of 3 of our rows. So we can do this using these print statements, and we could put this entire thing inside a function called printBoard and pass in the parameter of board. So what this is useful for is that every single time a player moves, we need to show them how the board looks like after we added their piece. So instead of writing all these lines every single time we need to print a board, if we put it inside a function, we can just call that one line every time we need to print the board. And this is how we would do that. Print board, and then we are printing the board, which is just the dictionary we're inputting into our function in this case. So now let's get to the actual gameplay part of the tic-tac-toe. We have to keep our end goal in mind before we just start writing the game code. Usually, if we have a game, we want to give the user an option to restart the game. So instead of writing the game code and then trying to add a while loop at the beginning and adjusting a lot of indentation, it would be easier just to write a function that takes care of our gameplay and then call it at the end and then incorporate that into our restart method. We're not going to be writing the restart method in this lesson, but we'll get to it next time. But we need to keep that end goal in mind as we write our code. So we are going to call or create a function for our gameplay and call it just game. Doesn't need any parameters. It's just a code segment that takes care of the gameplay. And just so we can have this down, we're going to put this pass keyword and put this function call here because we don't want an error as soon as we start writing our function. We still need to brainstorm what exactly is going to go inside in this function. So for now, we're just going to put a pass that tells the compiler as I'm going through the lines, just pass over this line. Don't worry about the fact that there's nothing inside this function. Don't give me an error. But once we're done with this, we'll write all of our code for the gameplay inside this function, and at the end, we will just call the game function like so. Name of the function, parentheses. So before we get started with the gameplay, we need some information from the players, and the players need some information from us. Let's think about what we need to do to begin the game. Initialization is just starting out the game and assigning variables so we are ready to set up the rest of our gameplay. So if you want, you could brainstorm some ideas, pause the video, and play when you're ready to see the solution that we will discuss. Alright, I'm assuming you have a couple ideas on how we're going to start the game. So let's go over some of what we came up with. Since tic-tac-toe is a two-player game, it would be a good idea to ask for the names of the two players. This will help us keep track of whose turn it is, and it will also have help with assigning pieces. We would have to tell player 1 that their piece is X, we could tell player 2 that their piece is O. So this is also what we have to do in initialization. We ask player 1 for the name, tell them for their piece, tell them which piece they're using, and do the same thing with player 2. And after that, since this is a tic-tac-toe game in Python, and we don't exactly know how to use like a tic-tac-toe board in Python, we are going to be using numbers to represent our board. We also need to show that to the user, and that will be part of our initial process. So we have to show our demonstration that we did with the 1, 2, 3, 4, 5, 6, 7, 8, 9 in the positions of the tic-tac-toe board. So let's get started writing our game function. We're going to start out with a simple let's play tic-tac-toe so the user knows that they're actually in the right program. Then we're going to ask player 1, what is the first player's name? Remember, we have these are input function, and in parentheses we would just write our question as a string. Whatever the user inputs will be stored as a variable to player 1. After we get player 1's name, we're going to tell them, okay, player 1, your piece will be X. This lets player 1 know that their piece will be X. We do the same thing with player 2 using the input function. The only difference is that we tell them that their piece will be O. After this, we have a couple of print statements just demonstrating how to play. Now that the pieces are set, let's see how to play. When it is your turn, select a number between 1 and 9 to move. The board below shows where your pieces will appear depending on the number you choose. So this is just explaining how our demo works and how they're going to play the game. Instead of clicking spaces on the board, they will be entering a number that will correspond to a position on the board. We have our demonstration after that. That's what this is referring to, a number between 1 and 9. The board below, that's the demonstration board that we made a few slides ago. And once the user sees how the game is played and knows what they have to do on their turn, we can print, okay, let's get started. We have to remember, all of this is inside a function. So just this code alone won't do anything. In order for this to actually run, we need this game at the bottom that will actually call the function and execute all of this code. You may have noticed a bunch of backslash n's here and there. We'll see how it looks like when we run the code. The reason why we have those backslash n's is because we want these spaces to appear in our game, so it looks kind of neat and organized, not just a bunch of jumbled up text all in one big paragraph, and it's easier to see our code. If you want, you could add even more backslash n's to make it even more neater, but this is just minimum number of new lines that we decided to incorporate into our initial program. And it works exactly how you want it to. It prints out what we needed to print. When we use the user input part, it correctly uses the user's name and tells them what their piece is, student 1 and student 2. And also our demonstration appears as we want it to. The user can see the board and the numbers that correspond with each piece on the board. So after we initialize or just our demonstration, we finish our demonstration, there are things that we need to keep track of, so we should initialize those as well. The three main things we need to keep track of are the player whose turn it is, their piece, so we could put it on the board when they move, and the count. And this is the count of the number of turns that have happened so far. We will get into more why we need count a little bit later, towards the end of this lesson and the start of next lesson, but for now let's focus on the other parts. Since player 1 moves first, we assign their name to turn. Remember, player 1 is just a variable storing player 1's name. So this is not just a variable storing a variable, it's a variable storing what is stored in this variable. Maybe a bit confusing at first. All we have to remember is that player 1's name is stored in this variable, and we're just giving it to the turn variable. And since player 1's piece is x, we assign x to the piece variable. And at the beginning, since no moves have been made, count will be initialized to 0. Just a note about the indentation. All of this is at the same indentation as what is inside our game function. You can see this from before. Our print OK, let's get started, is at the same level of indentation as all of our variables here, because this is taking place inside our game, not inside some loop yet. We haven't really printed anything out in our code, so even if we run this code, we don't need to test. The test is not really necessary, only if you want to make sure that you use the initialization syntax or creating a variable syntax correctly. That would be the only time. If you want, you could run the code at this point, but it's not 100% necessary. Now, since we have to repeatedly ask the user for input as part of the gameplay, we will definitely need a loop. And this will be a while loop because we don't know exactly how many turns it's going to run. The game could end at 5 moves or 6 moves or 7 moves or however many moves. So it would be a better idea to use a while loop in this case, since we don't know how exactly our game is going to last. And now we need to think about what we need to do inside the loop. If you want, now would be a good time to pause the video, come up with a few ideas, and play when you're ready to move on. Okay, let's go over some of the things we need to do inside our while loop. Our first step is to print the board, so the user knows what is going on in the game so far and what happened in the current move. The next step is to prompt the player to actually move. Their move should be a number between 1 and 9, and we should make sure that by checking for validity. If the move is indeed a number between 1 and 9, then it is valid, and it makes it to the next stage. If it is an occupied space, we know that it's not valid, so we need to ask the user to do a different move. So all of that is just covered under this one algorithm here. We check the move for validity. If it is valid, we increment count by 1 because a move was successfully made, and we update the board. Otherwise, if it's invalid because it's not a number or it's already a filled space, then we'd have to display the invalid input message, not update the board, and then ask again. So let's move on to actually writing this part of the code. This while true loop is what we're going to use to continuously ask the user to make a move until they make a valid move. This is just a note for indentation. This while true loop will be at the same level of indentation as the variables we just made, and whatever is inside this while true loop will be one level of indentation inwards. The first thing we want to do in our gameplay is print the board just so the user can see what is going on so far, and they know what type of move they should make based on what's going on so far. Alright, before we write the code for the next part, let's develop a visual plan with a flowchart. So flowcharts are useful in programming because we can plan things out before actually writing the code. We may have a lot of ideas, but it's better to get it down as a plan instead of going directly to code it. It might require a lot of trial and error if you go directly to code it, and especially with a complicated situation like this, it's better to have a plan before you go into actually writing the code. Our first step is to create a variable called move and assign it whatever user inputted move that is made. They should enter a number between 1 and 9. Now we have to check, is the move a number from 1 to 9? And the way we will do this is using our board dictionary. We know that the only valid moves that the user can make are strings that are either 1, 2, 3, 4, 5, 6, 7, 8, or 9. Remember, the board dictionary is looking at keys that are strings, not numbers, so we don't necessarily have to go that route of casting integers to make sure its user input is valid. So we could just check if the move that they made is a key inside the dictionary, and then we know that if it is, we also have to check that the move spot is empty. If it is empty, then we know that the user made a valid move, so we can add their piece to the board at that spot. And we are done, so we can move on to the next thing in our loop. However, if we make it to this point, the move spot is empty, and that check turns out to be false. So let's say somebody else already moved in that spot. Then we have to let the user know that that place is already filled and that they should enter another number. So we have to skip back up and ask them to enter user input again. Another case is that they don't enter a number at all, so the move is not in the board dictionary. In that case, we tell them invalid input, and they should enter a number from 1 to 9. Once again, we'd have to jump back up and ask them for a move starting from the beginning. So we discussed all this coding for these boxes, but let's think about these arrows. As we do these arrows, you can think of them as the continue keyword that we learned about with loops. They're stopping the current iteration going back up to the top. Now would be a good time to just pause the video and try to implement this code that we came up with in a flowchart into actual Python code. I'm assuming you had a go at it. And let's go over how to actually implement this code. We have our while true and print board from before. This is just a note for indentation. Our first step was to prompt the user for a move. We created a variable called move and assigned it user input. We get the current player's turn using the turn variable, and we tell them, where do you want to move? So, like for example, the first person is moving, we would say, student 1, where do you want to move? And their move is stored in this move variable. Then we check, is the move in the board? And remember, we are checking if this move variable, which is the user input that they entered, is a key inside this board dictionary. So we're making sure that it is 1, 2, 3, 4, 5, 6, 7, 8, or 9. If it is, we have to do another check. We have to check if it's a filled space or not. If board of move equals space, what does this mean? Let's break it down piece by piece. Board move, and the move is inside square bracket, is checking in this board dictionary at the key move. This is getting the value at that position, at that key. We're checking, is that value equal to space? In other words, this is checking if that space that the user wanted to move in is empty. If it is, then we can add their piece to that position in the dictionary. We can change the value in the dictionary so that it now stores their piece. And we want to do that because we want to keep track of what's going on inside the board in our dictionary. And since the move was successfully made here, we can increment count by 1 because we know that a move was made. However, let's say the move is in the board, we made it this far, but another player had already moved there, we would have to go to this else and print that place is already filled, choose a valid place. And in that case, we don't want to just go on to the next part of our code and start checking for win conditions and updating whose turn it is. Instead, we want to continue back up to the top of the loop, print the board, and tell them, where do you want to move? We don't want to switch the player. That's why we just want to continue. We don't count plus equals 1 because the move has not been successfully made. Another case where the move is not successfully made is if the move is not in the board. Let's say they enter like middle, a word like middle. That's not a number from 1 to 9. So we would let the user know, not a number from 1 to 9, that's invalid input. And once again, we'd continue, we'd use that keyword to go back up to the top and restart the process for asking them for input. We don't add anything to the board, and we don't increment count by 1 in either of the cases where it's invalid input. We wrote all this code to check for invalid input. Let's make sure it worked. We're going to test a lot of different cases to make sure our if-else statements are correct. Our first case is an invalid string input. So let's say instead of 1 to 9, they type just something completely out of there, like middle. And then we need to say invalid input, enter a number from 1 to 9. They print the board again, and it says, Sid 1, where do you want to move? If it's 10, that's still not inside the board dictionary. It's not a key inside the board dictionary. So we know that's invalid input again. We have to enter a number from 1 to 9. You get the same pop-up. Finally, if we enter something correct, you can see that it actually appears on our board. So why did it appear on our board? Let's go back to our function. Board move is being assigned piece. And once this is done, board will also be printed. So that's why it will appear on the board, because we have updated the board here so that at the fifth, at the key that is 5 inside our board will now have a value of x. And later when we print the board, that will also appear. But the thing you'll notice in this code is that even after we move, when we made a successful move, it still says student one, where do you want to move? And the reason is we haven't gone through the code for changing turns yet because that comes later on. And we are just checking for user input validity at this point. We still need to check for win conditions and changing the turn. So for now, this will just be stuck at student one, but we could still test our code for validity checking. Let's say student one enters 5 again. That place is already filled, so we have to choose a different place. Let's say this was student 2, and they wanted to move here. Well, they can't because that place is already filled, so we would have that message and it successfully shows up. Once again, at the end, it asks student 1 where they want to move, and this is just because we haven't updated our code so that it changes which student is asking or which player is asking after each turn. That is something we will look into next class. So talking about in the next class, our exercises for this week will just be preparation for the next class. Um, Instead of exercises, we're just going to have one exercise for this week, and that is to develop an algorithm or just brainstorm an algorithm to check if a player has won. Based on our dictionary, how would we check if a player has won? You don't have to write it down once again, you can just brainstorm it. Some things to consider are when should we start checking? Do we have to check after every move? For example, I can't win after the first or second move because it's not possible to have 3 in a row yet. So that brings up the question, after how many moves do we start checking? What's the minimum number of moves for someone to win in this game? Because we don't want to have to check if we don't have to. We don't want to check if there's 3 in a row if there's only one piece on the board. That's not necessary. So another thing we have to look at in order to accomplish this is just something to note that will help us in our code later on. We would have to use this type of formula, this Boolean, to check if a player has won. We have to check if a something is equal to something is equal to something is not equal to space. This may look a bit confusing for now, but this is just a hint. And if you're thinking about, and you're supposed to be thinking about what should I replace A, B, and C so that I can actually go to my board dictionary, that's another hint, and check, do I have 3 in a row? The thing is, we have this not equal to space because if there's 3 spaces in a row, that's not a tic-tac-toe. Nobody has won yet. So that's it for this week's class. Stay tuned for the next part of this tic-tac-toe program, which will be covered next